Yo, 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 what's up, everybody? Welcome back. Today we are working on our font rendering engine, because we have a terminal case was not invented here. And today's topic is trying to do, maybe render our first glyph. So we're a couple days in here. What we have right now is we have the ability to parse one TTF file. We haven't tried any others, so no guarantees there. And what you're seeing right now is us going through and rendering every single glyph. Sorry, not every single character in the range of A to Z. And that is going out to a folder right now. If I go to Exergy open out A ppm, here is what we have right now. We have something that resembles the letter A. So to get here, we opened up a font file. We parsed this like character map, and the character map tells us metadata about characters and where in this like glyph table they are. Kind of hand wavy. We're skimming over a lot of details here. The glyph table tells us kind of how to render this thing, and what it tells us is there are two types of lines. I guess I guess kind of everything is a Bezier curve, right? But in some cases there are two on glyph points next to each other. In that case, we draw a line. In the case where there are some off curve points, that means that we should draw a Bezier curve. So like they might have here, it is likely that these two points likely are supposed to be drawn with a third point here, which is kind of supposed to make this look like this, like a little rounded, right? We are not really handling that yet. We have parsed this out, but we have not drawn the Bezier curves yet. Let's see. Maybe I can show that. If I go to like main, maybe we can say that in the Bezier segment, maybe let's try to draw some lines, like this, where maybe we'll draw like the Bezier point in like a different color or something. So we'll like draw a line between A and B in green or something. Hold on. We can do this. So between A and B will be green. Between B and C will be green, and then between A and C will be black. Okay. Let's and this will be called point C because we can't. We're name colliding. Okay, hold on. Let's try that for a second. Fuck. One sec. Okay, here we go. So if we go back to letter B now, here we go. So we see the green lines are kind of showing like the Bezier curve that we're supposed to be drawing, and we're not doing that. So that's kind of the goal for today, is to kind of make these things look rounded like they're supposed to, and then fill them in like they're supposed to, right? Because like in here we're supposed to be like color in the stuff in here and like leave the stuff behind blank. And we're also missing some sort of like wraparound case here. So these glyphs define like these curves, and I think that there's supposed to be an implicit wraparound to the beginning that we're not really handling in all cases. So we have to fix that. The way these things are stored, they are stored as like a series of on curve and off curve points. So something like this, which is a very strange way to store it. But if you go here, you see like 0 and 1 are on points, we draw a line, and then we have like 2, 3, 4 are all off curve points, which means that we have to like resolve which point is like between 2 and 3 that are supposed to be on curve, and then draw a Bezier between that. So we've kind of resolved all that, and now we have to just draw something. B is looking upside down. Yes, everything is upside down, actually. The B is the best offender, the least egregious offender. This A is much worse, as is this this F is pretty bad, this G is pretty bad. So like let's fix that first, actually. That's like a good point. Let's do flip characters. And I guess let's just start writing some code. So to flip them, it should be as simple as just inverting Y everywhere, because their coordinate system is kind of like, do I have a color paint open? Yeah, their coordinate system is kind of like hand wavy. X goes this way, Y goes this way, and our image space has like Y goes this way, X goes this way. So you just have to like flip Y. which should be pretty straightforward. We just have to go everywhere where we use these things. We just go y flip is gonna be like take the height of the image, so image h. What do we call this thing here? Out h here, and I guess we'll just go like y flip minus this stuff. Okay, like this, and then we should be able to do the same thing here. Flip minus whatever we were drawing before. Okay, wait. Almost there. And instead we got nothing. So what am I doing wrong here? Oh, I guess we only want to flip y. We can't do this by like having a x component in there. That's annoying. That's annoying. So we actually have to do like some sort of function. Flip y with a is a I vec2, I guess, and height is a I64, and we return an I vec2, and we just do the same thing, where we do like return in 0 and height minus in 1. There we go. Better. So here, where we're doing y flip, we can just do flip y like this, and like this, and like this, and like this. All right, let's try that. Fuck. All of these things do, in fact, need the out height here as the second parameter. Fuck. Really? These things are all I16, I guess? All right. All right. There we go. A, B, C. Wow, they're right up now. Let's go. Let's go. when we for once use an input format with origin bottom left, we no longer outputs OpenGL where it would match, but PPM, we can't win this game. Yeah, we get fucked us. Okay, let's try to fix the fact that some of these characters, like all of them really, they don't draw the last line. So how do we do that? Somewhere we have our like glyph segment iterator, and he walks all of the points, and he says, as soon as we get all the way to the end of our array, we are done iterating. Now that is no longer the case. So I think we just want to take out this -1. Surely this is gonna like crash because we're gonna index it of bounds. And we should just be able to, maybe we like do some sort of like wrapping here. Glyph x coordinates len, like, can we just do this? Does that kind of just fix it? I guess here also we need to do probably like this. This seems wrong, by the way. Oh no, that's right. Never mind. It's right. It's right. Okay. Oh yeah, baby, look at that. Are our letters complete now? That looks pretty good. Looks pretty good. Looks pretty good. I'm looking for anything that looks kind of fucked up. This O looks kind of fucked up. I don't know what's going on here, but surely we've done something wrong. Q, again, we've done something wrong. Somewhere we're like connecting, we must be connecting a point that we're not supposed to in here. Like the O, it looked like here we're like bridging two curves that we're not supposed to for some reason. S also broken. Also broken, which is a little concerning. Yeah, I wonder what's going on here. Can we like only draw the letter S and try to inspect it a little bit more? So can we look at maybe instead of going over all characters, can we go like Boom, 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 boom. Maybe we move all of this into something. Render character. And if we put all of this in here, he's gonna tell us that he's, mad about some stuff. What's he mad about? He probably needs some sort of renderer. I guess all of this stuff can go in here. Sure, all this can go in there as well. And then he needs some sort of renderer. And he needs the... Here he can probably calculate the width and height from the renderer. Like this. Now he's mad that he's missing an allocator, as well as a TTF parser, or TTF as we call it, subtable, which is, I think, supposed to be some specifics format. I think it's like CMap table subtable 4 or something is the only one we support, and then the character that we're rendering. Then he also wants an output directory. Gross, dude. But I guess that's fine. Okay, so now all of this just we call render char with alloc c TTF parser subtable renderer and out there. And presumably this is gonna get mad at us in some way, shape, or form. Yeah, he's gonna be like, calc height doesn't exist. That's a really good point. We do have to spell the words right if we want to use them. And then presumably this thing has to fail because there will be things inside that are writing to disk, which is a failable action. And then we do this instead. Okay, and then out H is mad because this doesn't fit anymore in an I16, which is annoying because it used to be a comp time value and now it's like a runtime value. Silly Zig. Why you gotta be like that? Okay. Chillin'. Okay. So now we can just call render char directly. Render char, I don't know, man. With the letter C. Or S is what we were trying to test, right? We wanted to look at the S and see what the fuck is going on with that thing. Okay. Okay, so now what do we want to do here? I guess we want to like maybe we log like the number of contours 1. So this is one contour. One contour that goes all the way around. And somehow that one contour is not making it back. So why the fuck not? I suspect that we have, I remember looking at a confusing case somewhere in here. So how do we do this? How do we do this? We look at these points and can we render? It would be kind of interesting to render the on curve and off curve points differently. It might be interesting to do that. So can we do like a let's think about this. We could like export points as well, but that's like annoying to do in our current iterator. We might have to like make like a separate iterator and export points and show their on curve and off curveness. Or yeah, it's probably easier to do it that way. So can we just go like glyph point iter? Okay. And we can probably get away with skipping a lot of stuff here because I don't think we have to keep track of contours anymore. I don't think. And our output here is just going to be a struct, which has a point as an IVEC2, as well as like on curve is going to be a Boolean. Okay. To init this thing, we just do this. Okay. Everything else is default initialized. And what are we going to do? We're going to say, wow, we are less than all of our x coordinates length. Yeah, we will do something. Here, this get point thing is kind of overkill now. It's literally just like take the value here. So the points are stored as like differences from the last points. So we have to like accumulate them as we go, if that makes sense. So we go like, oh, this point, the last point was 5, 5, and this says 1, 1. So our new thing is 6, 6, right? So here, I guess we just do self like this. Kind of guess all of this stuff kind of just lives like directly in here. And presumably everything else just kind of goes away because everything else is about like curve drawing, which we don't care about right now. Okay. Yeah, that seems pretty straightforward. No while loop necessary here because there's no like continue cases. And then here we just use self IDX like this. Okay. So we go add this shit. Our position is going to come from the accumulator, and the glyph flags are coming from this guy. If we're on curve, we're on curve. Chillin'. Okay. So now we should be able to say that we want a glyph point iter as well. Point iter is a glyph point iter, and while point iter.next, we have some point we want to look at. Point. And we're gonna say, I guess it's literally just like draw a circle at that point, right? And so this is 0.0, 0.1. I guess we'll switch the color based off of if it's on or off. So on color is going to be like a renderer color of our red, maybe? Sure. I don't know why I have alpha in here. I don't support alpha, so I don't know what I'm expecting here, but whatever. And then off, we'll call it blue. Fuck it. So here we'll just say const color is equal to if point on whoa. Why is it confused about the type here? Whatever. On curve. It's not auto-completing correctly, but I'm pretty sure this is right. We will say on color, else off color. Wow. Wow, wow, wow. And then here we probably need to apply the same offset here for it to match up. So here we need to go point offs is equal to point dot point plus offs or something. Okay. Hello, broski. Hello. And then here we're told we still have glyph segment iterator. That's probably why I was confused. Glyph point iter is probably more what we want here. Okay, no iter next at 645. Why? What the fuck? Oh, oops, I fixed the wrong one, I think. Oh, I hacked up the wrong one of these guys. This is supposed to be glyph segment iterator. And this one's supposed to be glyph point iterator. Oops, my bad. And this should return a glyph point iterator here. And then did I fuck up this? Yeah, we're chilling. Okay, let's try that. 651, he's mad about this thing, which, ugh, gross. I hacked up the wrong one here as well. This goes here, this comes back up here. No wonder everything was mad. I just fucking like ruined everything. No field contra RDX and 466. Oh my god, I fucking broke the fucking member variables of the wrong one too. My life is so hard. Okay. 562 is mad because oh fuck, I fucked up. Oh my god, dude. This is what I get for copy pasting. Okay. Now are we good? Fuck! Glyph segment iter here. Glyph point iter here. There we go. We're getting closer. What's he about? No field name pause in output. Point, we called it. There we go. We got there. Okay. So now if I refresh here, we are close. We forgot to flip Y, I think, in the point rendering. Flip Y with out H, I guess, and I think we had to endcast this. Okay, that's looking pretty good. So red is on curve, blue is off curve. And I guess what we're seeing here is we probably start here and then walk all the way around and end up back here. And I assume that we're doing something stupid if the last point is off curve or something. I assume that's what we're doing. So here, let's see, what do we do here? We say, if A is on curve and B is on curve, that's a line. Cool. Else if B is on curve, continue. Okay. Otherwise, if 2 points away from now is greater than or equal to glyph coordinates len, I think that I don't want this since we handle the wraparound now correctly. I don't think that's the problem, but it's worth looking at. Oh, wait. That's interesting. So we've done something else here, but I don't know what. Can we prevent ourselves from rendering? Can we only render the green lines? And let's not draw these circles either. That's annoying now. No reason to do that. Okay, refresh. Okay. And then we're missing another green line that I'm supposed to draw. There we go. I actually wanted to get rid of this line. Okay. So now anytime there's a curve, we're only drawing the curve points. Okay. And so now at the end here, we're getting to this one. And for some reason, we're drawing a line out into like the fucking nowhere. Even though there's no point over there, we are going over there like idiots. And probably that's because we are accumulating. Yeah. So we are like, you know how we were saying before that each point is relative to the point before it? Well, this first point is supposed to be relative to 0, 0. But here we're like accumulating that point from the last point. I bet you that's what's happening. So here we probably have to do something like when we wrap around, we have to be a little bit smarter about it. We can't just say like take this thing and percent this shit. Here we have to say, like, as we find the point, we have to say, like, if I is equal to 0, x act equals 0 and y act equals 0. We have to reset the accumulator. Okay. That's not good. I kind of thought that would be it, to be honest. Oh, wait. If IDX percents... Yeah, the effective index, wrapped index, we'll call it. Wrapped I is equal to this. Okay. And if that's equal to 0, that's when we reset these things. There we go. Let's go, baby. That fixed that one. And then can we run the whole fucking list again? And look at them all. We do need our character iterator for that to work. Okay. And then can we, like, just get back over here somewhere? Okay. A. B. C. This looks wrong. But that's because this is off curve, so this is supposed to be, like, kind of go like this. So I think that's kind of fine. D looks reasonable. E, F, G. All of these look okay so far. None of these look... O it still looks kind of fucked up. Okay. Unless this isn't an O. No, this is definitely an O. What does, like, O look like in this font? Do I have, like, a font browser? Preview fonts. Here we go. Can we look for, like, hack? How do I preview it? Open in font viewer. Oh, here we go. Can I just open a font file in here? Hell yeah, dude. Cannot read font. That's super cool. Love that. Can we just go over here and look for hack? Can we do they have, like, a demo somewhere? Surely they have, like, pictures here. Yeah, so yeah, there's nothing, like, fucked up about the it depends completely, actually, on, like, how this is bridged. The fact that it bridges twice is kind of interesting. And I wonder if there's, like, something about, like, the way the Bezier curve is going to end up being drawn that means that this actually isn't a problem. I actually don't know. Let's see if we see... If the rest look okay, maybe we kind of move on. A has the same shit going on down here. A similar thing. But it could be kind of normal. Did you see this font viewer? Is this online? Browse. Bump, 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 bump. Oh, that's kind of fun. Okay, anyways. Oh, this is kind of cool for sure. Can I, like, zoom in without it, like, getting everything fucked up? I decline. Yeah, so they don't seem to have that same behavior, but maybe... Yeah, we're doing something maybe stupid then. Right? They're rendering their off points as red. So their point colors are inverted from ours, but it's very similar. And yeah, I wonder why this is happening. Can we only draw one contour? Let's try that. Let's try doing the letter A here. And can we just make it so that we only draw one, like the first contour here? So here we'll go like end PTS of contours 0 plus 1 or something. I think that's how you're supposed to do this. Interesting. Oh, you know what? So I bet what's happening here is like the last point on this contour on the A is an off offline point, right? And instead of wrapping around on the contour, we're probably supposed to draw a Bezier that lines up with this being the next point, right? Like, how do I show this? This is probably supposed to be like, so the way this works is if you have two off curve points in a row, there's kind of like an implicit on curve point in the middle, right? And probably what they want us to do is they want us to draw like this Bezier curve. But we're getting kind of fucking stupid and we're saying like, oh, let's go like, we're going forwards. So we'll advance to the next point. And the next point is on like a different curve. So we're supposed to wrap around in this case and we're not, would be my guess. So I guess what probably makes sense here is that we should be calling like get point. Every time we get a point, we should be passing in the contour index. Which we kind of have already. We have the contour IDX here. So what we should be doing is when we do this wraparound shit, we shouldn't be wrapping around relative to the whole thing. We should be saying like contour lang is self glyph end point of contours self contour index plus 1. Sorry, like this. And then here we present contour len. And probably down here, we also present contour len. But we can't do that either. Because, then our index will be like, we need to like offset, fuck. Wrapped contour, contour index. Okay, this is what we're gonna do. So we say, yo, this is our contour len, right? That makes sense still. And then we have to do like index minus, we need like contour start, right? So this is gonna be like this, right? We're gonna go back one, right? Unless contour IDX is 0. Otherwise, then we just write 0. Else we do this. That seems reasonable to me. Then we just do index minus contour start percent contour len plus contour len. Okay. So this is going to be self-wrapped contour index of I. And then here we're going to do self-wrapped contour IDX of index. Might be nice if the iterator had current contour slice. Yeah, that's not crazy. That might make things easier, huh? Index out of bounds. So we did something wrong here. Oh. We added the wrong thing. Okay, integer overflow. So IDX minus contour start is no bueno. Because why? Because IDX... I actually don't understand. So let's look. We have frame 7, we have IDX, contour start, contour index. Is it something to do with like... Yeah, I see. So we somewhere like first contour point, we adjust later, which is a problem. Yeah, okay. Fuck me. So what is happening here? We're like, find me the first contour point here, which is just kind of used here. So maybe we can kind of cheat. And we can kind of just do this. No, we can't. Oh, fuck me, man. So we're trying to like say, what do we even use this for? This is only used here. So we can just kind of like ditch this whole concept, I think, because we're going to wrap around automatically. And here, instead, we just kind of say our point will automatically wrap around like this, and then we can do B here. Yeah, that seems reasonable. That seems reasonable to me. And then it looks like we have a known bug here as well, but that's fine. Okay, I didn't really want to run this in a GB, but that's fine. Can we look at the A now? Okay, so now this looks a lot more reasonable. We're rendering like the actual outline. And then can we go back to using the glyph x coordinates len in here as our to draw all contours? Fuck GDB. He's mad because now what? If we on the second contour we fuck up now. Okay. Okay. So our wrapped eye comes from what? We're at index 49, which is out of bounds. So why is that happening? Where is this coming from? This is coming from index plus 2. So shouldn't the wrapped eye here be going back down to 0? What's happening there? What is happening there? So we have contour index is 1. So in here, we should be like, contour index is 1. So we're on this path. This is the contour start. The contour length is this thing. And then we say, hey, I want to be, how far am I relative to the start? Mod contour len. So how can I ever end up out of bounds? I don't understand how I can ever end up out of bounds, because the contour len here must be the end point of contours is like inclusive, if I remember correctly. Maybe it's not, but I thought it was. It would be kind of interesting to try to run like breakpoint on this function only in the fucked up case. So maybe we can do like a breakpoint here if index is 40, if I is 49. Right? Is that the case we're in? Oh. Up, up, up. Backtrace. Frame 7. Frame 8. What, am I stupid? Frame 9? There we go. So here our I is 49. Yeah, so can we just do like condition 1 I equals 49. Run. No, didn't work. Info breakpoints. Stop only if I equals 49. Okay, what if IDX equals 49? Still no bueno? That's annoying. Dude, hello? Why isn't my breakpoint hitting? We're breakpointing at 524 if I is 49. What the fuck, man? Why? Oh, why don't my tools work, man? Can we do break wrapped contour index? God damn it. God damn it. Can we break on like the entry point to this function? Be this. And then just be like condition 2 IDX equals 49. Does that work? No? Oh, why do the tools never work right? That's so annoying. Okay. Do we just fucking spam it? Why is this sometimes like what's going on here? Oh, it's just a fucking lying piece of shit. What the fuck? But that might be another clue actually. We could maybe do it if self. Oh no, it's fine. 5, 6, 7, 8, 9. Okay, we're just gonna spam until we get to 49. Almost there. 28, 29, 30, 33, 4, 5, 6, 7, 8. Okay, 41, 2, 3, 4, 5, 6, 7, 8. What the fuck? What? We never had it at 49, man. I just want to see what's going on, man. That's so fucked up. Fine. We won't use tools then. I guess we'll just fucking write down numbers with prints. It's so stupid. I don't even know what I was trying to inspect here. Okay, we'll start here. That's so frustrating. Okay. And then I guess we also want... We know that 49 is out of bounds, so... I guess we'll just see. So here we have index is 49, contour... Oh, I'm an idiot. We need to subtract contour start here. So that's why it worked for the first one, not the second one. There we go. That's not good though. That's not good. So what's going on here? What is going on here? Probably... we have to, instead of going back to 0, use the first contour point, which we've lost. Because he's now calculating relative to 0, 0 again. Oh. So what's happening here is he's like, this line here is this point. It's the same as this point to this point, right? Since these things are relative, this first point in the contour started from this last point over here. So he's going like, oh, to get from here to here, you have to move up and to the left. And so that's what he's doing here, except that it's no longer correct. So when we wrap around, we have to remember where this contour started. We don't have a choice, which means we have to go back to adding that concept back. So that's like here, we just need to store first contour point. Okay. Okay. So where do I stash that then? That's the question. I guess when we increment the contour index, we have to stash that shit. So how do we do that? I guess we just call this. Does that work out? So here we say wrapped contour point is going to use the current contour index. So this has to get incremented first. And that seems pretty reasonable. Then off rip, we have to say first contour point is equal to 0, 0. I guess we actually kind of want the end of the last contour point. Like this. Yeah. So this is the last contour point of previous. Last contour, last point. There we go. Yes. So that way, when we wrap around and we try to calculate the offset again, we can calculate the offset from that point, and then at the beginning, we can just store 0, 0. Then here, we say last contour, last point, like this. That sounds reasonable. Okay, he wants this to be a dot pause, probably. Okay, and let's see, XGG open. And what letter were we on? It was like lowercase a. And here we go. Refresh. Still no good, huh? Still no good. Why not? Last index is 0. Last point is this. Oops, wrong fucking character. Zig build, and then go away you, and then come back you. Okay, so whoa. Why is that not happening at the end? Shouldn't we be seeing here? Index is 0. Yeah, that's just not happening. Why the fuck not? Can we write down wrapped I is this? What am I doing wrong? Um. Oh, because we have to check if this is the contour start. Ah, I see. So this isn't if it's 0. It's literally if it's like contour start. God damn it, dude. So this is this. Okay. Uh-huh. Uh-huh. Okay. And then here we have to go if wrapped eye is self contour start or something. Let's go! Let's go! Okay, I hate the fact that contour index, like stateful APIs using contour IDX are gross. I just don't really like that because it makes it so that this code up here is very confusing, right? Where we have to like call like get point, then increment the contour index. Like this is like kind of sketchy. It would be nice if we pass those in, but I think that we're like at least doing the right thing now, so I can kind of handle that later. And can we render all the characters again and just kind of see where that goes? Okay. We'll start at the beginning. A. B. Okay. Good, 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 good. Nothing here looks crazy. Everything looks fine. The O's looking a lot better now. Q's looking good. R. All of these are fine. Nice. A's looking pretty chill now. B is good. D. Anything with these like holes in the middle are looking fine as well. E's looking good as well. Why the fuck is there like a random Z in the middle of this? Let's go! The capital O. Let's go. Some of these are rendering off screen a little bit, but I guess that's just fine because we're not really handling that at all. Okay, so I think that we finally, it looks like all of these letters are like somewhat sane now. So let's go. That's pretty sick. That took a lot longer than I thought, which is kind of good because I was worried that we would run out of stuff to do today. And now I don't think that anymore. Now I'm worried that we're not going to finish. Hint, hint, pun intended. Let's go. P needs flipping. Did you trick me? Browse. LMNOP. I think that you were confused by a B or a Q. That's my guess. XG open out P ppm. That's fine. So is that. Those are both fine. You tricked me. You tricked me. How dare you? Okay. We need to, I guess now, render some Beziers. Render some Beziers. And the way we've done this in the past is pretty imperfect. What we've done in the past is we've gone and said, we have a formula that says, given 3 points, you're trying to render like essentially this curve, right? And the way you do that is this curve is defined as like an interpolation of this line and this line. So if you're at like, you know, P, like at time step like 0.3, you kind of move like towards this point and towards this point, right? You kind of get like a line that is like across these two things. And then you go 0.3 along this line as well, which will give you your point on your curve, right? And so if you're just like looking at that and you're going like, how do I draw this curve? Then what we've done in the past is we've just like sampled this at different time steps. So we're like, I don't know, like we'll just look here and then look here and then look here and then look here, right? And it's like, I guess you could do that. That's like, you know, that approximates it, but we can do better. We can calculate exactly, I'm pretty sure, where on the curve any pixel should be for a given y position, right? So if we were to like do the typical like walk down an image, right? If you're like rasterizing an image, you kind of go like line by line, top to bottom, so that you're going like in order of memory. And like what you do for like a line segment is you can kind of say like, okay, so I am at like pixel like this y value here, and you can kind of say like, what x value should that be at that line at that position, right? And that's really easy. You just like lerp. Isn't 3 just a midpoint? 3 what? I don't remember if I was talking about something that made that make sense. Um, so what you can do is you can just like interpolate your y values here, right? You go like, and then use that as like an interpolator for your x, right? So you go like this starts at like x0 and goes to x1, and then this goes like y0 to y1, and you can say like how far have I gone in y? Apply that same thing to x, and that's how we can like draw a line. So for a curve, I think there should be some formula that you can do that says like at a given y position, what are the 2 points in here, right? And since these things are quadratic, we can maybe assume that we have some form of like, negative a plus minus root 4ac over c squared or 2a or whatever the fuck the formula is. We can probably do something, but this is a little different than your like typical quadratic because like these things can be on like any orientation. But I think like the same thing applies, right? So if we're drawing like this Bezier, maybe so we'll draw like this one or something. We're gonna have like 2 points that go through any y, or maybe there'll be 0 points, or maybe there will be 1 point because this thing has like a start and end. But this thing would like continue on, kind of like imaginary, and then we just check this point, and we can check if like the time point for this is like in the range of 0 to 1. If it's in the range of 0 to 1, we're chilling. But otherwise, we just like discard it. So I think that we can probably do something like that. I think. If we go to this page, the digitizing letter forms thing, they're like use this formula, and you're like, oh, to draw a Bezier, and it's like, okay, that sounds kind of cool. Let's copy this and shove it in a Wolfram alpha, and try to solve for it. So I think this was this did not copy paste cleanly. This did not copy paste cleanly. So this was 1 minus t squared, 2t, t squared. Okay, so this is this. We'll call point 0 a. We will call this 2 times t times 1 minus t times point b plus t squared. Was it p2 is probably point c in this scheme? Yeah, it is. P sub 2. And then I guess we probably have to be careful about like things getting on the wrong side of the power. So was this t? This was probably not to the power of ta. This is probably a times on this side. Probably like this. Probably. So first of all, we're going to kind of hope that we can like graph this. This was supposed to be times to the power of 2, not to the power of t. And then can we ask it to like graph pt from t is equal to 0 to 1? From t equals 0 to 1 inclusive, a equals, I don't know, 4b. Okay, well, we do like graph this for t in range 0 to 1. Is that something we can do? Let's see. Fuck. How do I like graph a fucking parabola? First of all, can we do like Wolfram alpha graph function? Imagine ask an LLM to make a Wolfram query. God. Fuck! Why did I fucking click that? This is the stupidest thing I've seen in my fucking life. They do say type plot. Let's see if that helps. No. I know that you can like, okay, like I know that you can do like plot x squared plus 2x plus 1 or something, right? I'm pretty sure that will do what I want. And then it's like, how do we like, if I throw an a times x in here, does it like get confused? Yeah, at a equals 1 or something. Aha! And x, can I do like, at a equals 1 from 0 to 1? I think that that's what, yeah, from x equals 0 to x equals 1, maybe? Does it let me do that? Yes. Okay, this is what I'm looking for. Okay, so we're looking for this form. So plot this shit at a equals 4, b equals 2, c equals 5 or something, right? There we go, baby. From t equals 0 to t equals 1. Hell yeah. Okay, so this is like our Bezier curve, kind of. And we can now solve this thing for a specific value of y, and that will give us a t value that we can use to interpolate x. I believe. It will give us two t values, actually, theoretically, right? So, can we solve, say, let's copy this and say, solve this for t equals 5 or something. Sorry, for, solve pt equals this for pt equals 5? Is that what I want? Solve pt equals 0 where pt equals 5. Suggested substitute expression. 5 is equal to this shit. Nice. Okay. This is what we're looking for. So can we write like n here or something and then kind of plug this into... Hell yeah, dude. Nice. Nice. Okay, so this is like what we plug in plug into our code. And this is just like, you know, a variation of your like quadratic formula, right? With the like this thing essentially. Just like the terms are like all fucked up because like we have kind of these coefficients that are a little odd. So what are like the differences between these? We have the plus minus here, right? Because your quadratic formula is usually like, you know, negative b plus minus the square root shit 2a. So that's what's going on here. And then what's this version? So this is like... simplified? I don't think so. I think this is like a third variation. Because you can't really simplify any of these things. They've kind of like, they've already grouped like terms, I think. Unless they're saying like all of this. And a equals 2b minus c. Oh, it's probably something about like the bottom half. I see. They're trying to find all of the cases where this thing at the bottom is 0. And if they make a condition where that is in this condition, all of this stuff goes away. I see. Okay, so I think we just copy paste this one. Okay. So can we do like in our renderer, can we say pub function draw Bezier? Okay. And this is probably going to do something mutable, and probably it can't error. And I guess here we're going to have to do like solve Bezier. first, right? So we're gonna have some sort of like find Bezier t for y. That seems reasonable, right? So we're gonna have some curve defined by 3 points. Can we do like, I know we have this in main, I guess but we don't have it here, which is a little annoying. But we'll do vector I64, 2 of them or something is the other way around. 2 I64s, I think is the units we're working in here. And we'll just say A is an IVec2, B is an IVec2, and C is an IVec2. I guess we could do like, we could call this like canvas point or something. Just so that the, you know, even though they happen to be similar concepts, they're kind of used in different scenarios. Okay, so we have 3 points, and we want to pass in a y value of I64, right? So we can kind of sub this a little bit. So we can say that pt is equal to y, and then A, B, and C are still reasonable, I believe, because this is 0, 0.1, 0.2. Yeah, I think that the rest of this actually will make the letters work the way we want. Why is this different? For pt is equal to, like, do I just have to use, is it just that the letter here doesn't work? Yeah, I guess so, huh? So when I type y probably has like a specific meaning, and then it gets angry. So, fine. Fine, okay. So, can we like, pin to the top and just start copying? Negative AC plus AD plus B squared. Okay. Jesus Christ. How do we want to do this? I guess we actually only want the y values here. So I think we'll say this is AY, BY, and CY. That will make more sense. And we'll just say like negative AY times CY plus AY times Y plus BY times BY minus 2 times BY times Y plus CY times Y, because D is Y in this above. This is all square rooted. Which I think we have like stood math squirt because like integer square root is implemented differently. And then we say plus AY minus BY. Okay. This is the numerator. Denominator is AY minus 2 times BY plus CY. And then we return. I guess we kind of want to do this as floating point here, because t is going to be a value from 0 to 1. So we probably don't want to integer square root this. So we probably want to do like numerator is equal to squirt numerator, and then numerator plus equals this. And then we can do a float from it here. Okay. And then we just do return numerator over denominator. And then here this is actually like the plus minus term. Kind of like the offs term is going to be AY minus BY, right? And then here we're going to say the two options. Out 1 is going to be numerator plus offs over denominator, which means that this we want to be as an F32. Probably. Okay. And this also has to be float from int, I guess. And out2 is this minus that. And then here we return our two t's. Bezier t's. And here we're gonna have like A and B. Return A is equal to out1. I guess here we could just return two F32s. That's probably nicer. Okay. And this is so fucked that we need to write some tests. We don't have a choice. Bezier solving. Okay. So, can we create how do we like define a Bezier curve manually? I guess we can just kind of throw in some points on Wolfram alpha and see if we get like similar answers. Right? So we can do like pt is equal to 5 at a equals 4, b equals 3, c equals 1 or something. Fuck. Result is this. Why does it only have one answer? Oh. I just guessed bad coefficients. What if we try again? Do some points by normal interpolation. Oh yeah, that's a good point. That's a good point. So we could do like okay, let's get this out of the way. We can do like I think we actually have a function for this already. Maybe we don't. Yeah, here we go. Here we have an ability to sample a thing. So you're kind of right that we can do like vector to F32. We'll do two F32s here. Yeah. Okay, so here we can do like sample quad Bezier curve, given some points. I guess here we can actually kind of use any type here. Maybe we can't. Maybe we can't. Okay, so we go like 0. Let's start at like -2, 2. We'll go to +2, 2. And then we will go to 0, 0 or something. Okay. And we are sampling at time step. Oh, hold on. In this curve, it's pretty clear that it's symmetric, right? We should be getting like two t's at the same. We should get like this is going to look essentially just like straight like this. And so, right, -2, 2, 0. I guess we don't really know if this is kind of gonna like we probably never reach this point. Okay, fine. So it's fine. Let's sample this at like t equals, I don't know, 0.3 or something. Then we should be able to say, find Bezier for y, given 2, 0, 2. We want whatever point came out at y. We need like bigger numbers here because we're doing integer math on a lot of points. So let's do like 20, right? This will give us a 0.1. We were looking at the y value here, and we should get 0.3. Yeah, I think that makes sense. T's. So can we say std debug print the T's? And I guess std testing expect equal 1 0 something like. Let's just force a crash. Okay, so here we got not what I was hoping for. So here, oh, because 202 is not 20 0 20. That would do it. So that's not what we were hoping for. Not what we were hoping for. We were hoping that we would see the value we sampled at. Can we see what point we got? Let's just make sure that looks sane. So -8, 16, or 11. Yeah, that seems reasonable. So if at 0.5, we should be getting x equals 0 here, probably. Yep, x equals 0. And then the y value here is 10. Right, so what we should be getting, this is like 10, 20, 20. Sorry. How do we say this? We have, this is x0. This is 0, 10 is what we've got here. So we're hoping now to have some sort of formula where we punch in these y points and get t is 0.5 out of them. So did I just AY, BY, CY? And then I punch in y equals 10 here. Is it possible that I was wrong about the math here? I was kind of assuming that you could extract out the y values by themselves. That seemed reasonable to me. But let's see if this kind of works the way I want it to. So 0, 20 at t equals am I solving for the wrong thing here? Solve this thing. Yeah, I think that's the right thing. So we want to solve this thing for 10. So this gives me what I asked for, which seems kind of bad. Like this is 0.5, and this is 0.5, which means that like this math just isn't what I thought it was. T goes from 0 to 1. Yeah, I agree. But given an input value here of t at 0 to, like, there should be some t value here that creates an output here of y equals 10. Right? That's what I was hoping for, and it's giving me t equals 0.5. Oh, wait, that's right. I'm just a dumbass. Wait, you guys are right. Never mind. Never mind. Yeah, sorry. You're right. You're right. You're right. So this gives me 0.5, which is correct. That is correct. Oh, thank God. I was confused. Okay, okay, okay. Jesus. Okay, so we put this as for 0.1 here. Float from int. And we should also, fuck. Int from float. Okay, so this gives us this, and then we need to extract 4 t's. We want to ensure that one of the t's in here, we want to ensure that one of the t's is this. Yes, okay. So we'll say like any t. So I guess we're gonna have 2 t's come out. One is gonna be the one that we put into this. The other one is gonna be one that will return. We want to put the other one into this same function and see if we get back a y value that is the same. Yes. Yes, 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 yes. Okay. So here we have to sort this, I guess. So we're gonna say like t1, t2 is equal to this. If t1, we want the one that's closer to the original. So in t is 0.5, we'll call it like this. We say if t1 minus the absolute value of t1 minus int is greater than the absolute value of t2 minus int, which one of these two fucking things is closer, we swap them. So that we have t1 is always the closer, the one that was like the closest what we asked for. Then here we want to like test that there is, that t1 is very close to int, right? We want to ensure that these are almost the same fucking value. Then we want to use t2. We need to check here if t2 is greater than 0. Is less than 1. And it's greater than 0, right? If it's in like the valid range, then we want to sample this curve at t2, and we want to check that these two things are almost equal. That like 0.21 and 0.1 are almost the same. That feels close to what I want. Test them before sorting them? Why? I want to make sure, I need to, I'm testing the two numbers with completely different mechanisms, so I need to know which one is which before I get there. I'm pretty sure. Okay, within some threshold again. Oh, that's good. Okay, so now let's try, we're gonna do this for like a bunch of different points. So we'll call this curves, I guess. What's the point if it's not in 0 to 1? Well, I'm still hoping that one of them will still be closer. Yeah, I don't know. Seems fine. Seems fine. So curves is gonna be a list, some sort of like number of 3 canvas points. Okay. And so this is one of them. Okay. And then I guess we'll just kind of throw a few more at the wall. I don't know. I don't know. It doesn't really matter, I guess. So this, we want something like, I don't know, 40, -30. Then we want to go like up above that thing. So like up and to the right of it is like 80 and -10. And then we want to go like maybe like something like even higher and far to the left. So like negative, or we'll go like 10 and something that's like really far to the left, like 20. Okay. And then we go for curves. We do all of this again. Uh-huh. So we'll call this 0.1, I think, is reasonable. And then we say curve 0, curve 1, curve 2. And here somewhere we wanted to sample 0.1 here. Okay, curve 0 is mad because what? Oh, sure. Okay. Then we ended up with some nans. Can we... Okay, let's comment out this for a second. Just go back to the initial test. Okay. Then let's kind of say here, we probably fucked up one of these curves that so they're like not reasonable. So is this a reasonable thing? -15, -30 is like left and down. Let's see, is this the wrong thing? So here we have like -15, -30-ish, kind of like down here. Then we have 5, 15, which is like kind of like up here. And then we have like 10, 20, which is like up here. That seems like a valid curve. I think any 3 points is a valid curve. So who's getting mad about a nan here? This is coming at oh, because one of them might be nan. Maybe. Kind of liney for a curve, but yeah, I agree. I agree. um, so this is just like double nan, which seems pretty bad. Which seems pretty bad. Which means like what? Oh, because this is like the wrong fucking thing. I'm just dumbass. Curve 0, 1, curve 1, 1, and curve 2, 1. The 3 Y positions. That would do it. And then I guess we will make these canvas points, I guess. Which means that all of these things need to be integer. So fuck off point zeros. Okay. And then here we will just float from int on each of these guys. That should help. Float from int. Float from int. Okay, and then curve 0 is 139. What's going on now? Oh, wrong way. I'm a dumbass. God damn it. Is there no, like, clean conversion here? Does float from int work on these? That'd be kind of cool. Um, that would be cool. I don't really know if I expected that to work, but looks like it did. All one test passed. Let's go. And then let's add another point here. This one did not work because nan and infinity. Okay, so what's going on there? Negative nan and infinity is what we get for our 2 points. So we have negative 30, negative 10, 10. And we're solving for some y point of negative 10, essentially, right? We're saying is that what's happening? Oh, I guess, yeah, for each of these, we're kind of getting, like, the y value that is that point, no matter what. 0, 15, negative 10, because we're always at 0.5. 10, oh no, 10, 5, negative 10. No, it doesn't reach that high. It has to reach that high, though. We have to be able to, like, we are calculating a time step that is valid. We're kind of just, like, halfway through the curve. Unconditional, we're getting a point out of that thing. That point has to be valid, and then we are trying to find for that y point. And that's not working. Which seems pretty reasonable. There's probably just something stupid happening in here. There might be some, there could be some integer slash floating point problems in here. That's quite likely. Yeah, so what is happening here? We get our 2 t's. So this would happen if denominator is invalid, which was told to us as an invalid, like a thing from Wolfram Alpha that we need to be worried about. Right? So here we need to check if a plus c is not equal to 2b. How does that happen? So a and c, where the fuck are we? Oh, nice. We just accidentally hit that case, huh? 30 plus 10 is negative 20 is the same as negative 20. So we just happened to guess that that was completely unintentional, but that's very lucky for us. So we're in this case where denominator equals 0, right? Almost certainly. Denominator is this. Yeah, we're getting denominator equals 0. So in that case, what do we do in the quadratic formula if a is 0? Fuck off. Okay. Oh my god, fuck off. Holy shit, I clicked that X like 4 times. So a here is the x squared coefficient. So in some cases, the x squared coefficient is 0. And then this just becomes like a linear thing, right? So that's what's happening here is he's just doing like there's one exact location where this is true. Oh. Okay. Sure. So if denominator we'll do this. Denominator is equal to something. My poor little brain, I can't figure it out. Float from int of denominator I. And then here we just have to be like, if denominator I is equal to 0, we return this thing. So one of these, it's, I guess we'll just copy it. Negative 2b plus c plus d, where d is y, over 2 times by minus cy. And then we just return like this twice. So we'll say like linear function. I think we can do this. And then here we do need to do some sort of like, I guess we'll still do it this way. There we go. Yeah, divide equals like this. Let me do a little float from it here. And float from it here. Okay? So now we get negative 0.5, negative 0.5. It looks like we have an accidental inversion here. But I don't really see where. Oh, I missed the negative at the bottom. So this is like negative 1 times all of this. Okay, so we got 0.5, 0.5 here, which seems correct. But then he's mad about something else here after. What's he pissed about here? So this is in 172. We're saying, yo, I expect these 2 points that we passed in for the 2 values to be almost, oh, this is just the wrong fucking thing again. All right. I think we got there. Nice. Okay. So sick. Okay, now we want to sample for like a few t values. So here looks like const t's is going to be an array of f32s. And can we just be like, I don't know. I don't really have like much of a plan here. 0.1, 0.4, 0.8. I guess probably 0.5 is a good one to test. And then probably 0 and 1 are also probably worth testing. For t's in t, kind of slap all this stuff to the right, throw a little curly brace on here, and let's just see if they were still good. We are not. So what is going on here? Can we like GDB? Fuck. That's annoying. How do we fucking how do we like GDB our tests? Okay. So 1, 2, it's the third one. 1, 2, oh, it's this. 1. Okay. 1 to continue, 2 continue. It crashes. So how come? Oh yeah, I see. Okay. Okay. So T1 in T2 seems bad. Seems bad. So we just got the wrong thing. There's also a special case where b equals 0 and it becomes c equals y. Yeah, I agree. I agree. Okay, so where the fuck are we? We're here. So here we're like negative 20, 0, 20, 20, right? And we're doing it for in t at t is 0.1, right? So we have like this like 0.1 is at negative 16, 16. That makes sense. We're kind of like coming down the curve a little bit and we're like 0.1 of the way in. And so our T1 and T2 that came out, we're kind of like on the wrong side, would be my guess. And there's like probably some negative that we missed in here. And since we were only testing 0.5 before, it just kind of happened to work itself out because we were just kind of going from like the wrong end or something, would be my guess. Find Bezier T for Y. Okay, so let's just, Jesus Christ. I guess we just have to look again at the fucking formula. So it's negative AC, A times C, plus AD, where D is Y, plus AY, plus B squared, minus 2BY, minus 2 times B times Y, plus C times Y. Yep. And then we do plus minus A minus B. Yep. And then we divide by AY minus... Oh, this one's negative here. Oh, I fucked that up. Okay. Hold on. So when we subtract it, it's A minus B. This one has to be negative, like this. Zig test. Now, I think that it's likely that we just have some like imprecision issues here. I would like to see if these are within like 0.2 all the time or something. If so, we might just have to like increase the, increase something, but I just want to see if we get farther. No. Okay, so what are we looking at here? I should put a fix me on here. What if denom is 0? And fuck my life, dude. So we probably just want to like start like throwing in more logs here, right? Std debug print testing curve for curve this. Okay. And testing t value in t. Okay. So now we say we're like testing curve this, we test t value 0, we test t value 1. Then we testing t value 0.1. This gives us these things. Negative 16 and 16. Whoa, what is this? What are we logging there? This is the output point, or like sampled point is this. Then these are the calculated t values. Okay. So why is this wrong? Oh, down here it's the the sampled point. So we're getting like 1.64 and 1.6, but that's because of imprecision. So that's down here. Can we just like literally just do within like 0.1? I just want to see how bad it is. Calculated values, and then we'll say that this is the other point. Yes. Okay. We do need to write out any here. Okay. So 1.6 is not within. Can we go like? I guess we just want to comment this out. Like, fuck it. Okay. So here we say we're testing t value 1e negative 1. So the first thing we get is values 0 and 1, which is correct. Then we test value 0.1, which we sample the incorrect point. Then we test t value 0.4. And then we end up calculating t values 0.5, 0.5 again. Which seems bad. This seems bad. Yeah, there's got to be some sort of precision issues. There have to be. And it's, are we doing like any division in like here? We're doing multiplications. All of this is multiplication, so I don't really see any problem here. This should all be like very precise. Off's term, ay minus by. So we go. I wonder if there's like a problem in like the point sampling as well. There could be something there. So this is taking in floating point, floating point, floating point. He's lerping with floating point. I really don't see why this would be a problem. This feels like it's probably pretty good. Oh, but the sampled point is not integer. So of course this is going to be a problem. Of course this is going to be a problem. Right, because sampled point here is now 16.4. And of course that won't work if we're trying to sample a fucking integer thing here. Of fucking course that doesn't work. Of course. Which means that this stuff just should be floating point, I guess. I guess that probably just makes everything easier, huh? Probably. Probably. In which case, now everything in here wants to be two floating point numbers, and then everywhere we type float from it now is angry, because these are already floats. Uh-huh. And 104 is pissed off again, because again, everything in here is floats now automatically. Boom, boom. Boom, 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 boom. All right, let's try that. There we go. Okay. That's a really good sign, though. That's a really good sign. So this passed totally fine. I guess we didn't test this anymore. And we probably want to fix this test range as well. Sick. Sick. Looking good. So, that took fucking forever, but we did get to the point where we feel like our find Bezier T for Y is somewhat reasonable. Which means that if we want to draw a Bezier curve, we should be able to leverage this to do something. I don't know what yet, but we'll get there. So this is going to look very similar to drawing a line, probably, where we're going to take in some positions. Like this. And we are going to then iterate from the maximum, and we're gonna look at from like the minimum to maximum y value, right, of all of these. So we're gonna say like min a1 b1 minned with c1. This is gonna be the min y, and then probably we want to clamp this to the canvas. Max is going to be the same thing, but with maxes. And is there like a stud mem max? Oh yeah, there is. Hell yeah, let's just do it that way. Stud mem max of I64 of A1 B1 C1. Okay, and this should actually be min. I can fucking read. Max y is the same thing, but with max, we're gonna iterate. We're gonna start at like y is equal to min y, right? And we're gonna say, wow, y is less than max y. Is this inclusive? It might be. We want to increment y. Okay. And then we're going to do something. I guess we are going to try to figure out what our two time steps are. Right? So here we have A1, B1, and C1. And I bet actually, is there like pre-computation we can do here? Probably not. It's fine. It's fine. We'll just do it for every fucking line. Fuck it. We can always get better later if we need to. Sorry, I've been not very attentive to chat today because my head hurts. But it is funny just like glancing over and like, what the fuck is going on over there? I think that we have multiple references to Elmer Fudd in here, right? We're talking about, unless I'm not sure if this is like a reference to the like it's hunting season shit that Elmer Fudd does. But anyways, y'all are crazy over there. Okay. So probably everything in this thing needs to be float from int. I expect. Okay. Ask away, Pops got you. Yeah, you can ask, but I might not answer. Apologies. Also, I would not suggest getting career advice from me because I'm unemployed as shit right now. Okay. So now we have T1 and T2, and we can sample the curve for those two positions, I guess. And I wonder if like, yeah, fuck it. So here we like sample quad Bezier curve at A, B, C. Also, these things need float from it, which kind of makes me think that we should just at the very like off rip do like A, F is equal to float from int a, and this should become like a vector 2f32, bc, bc. Then everywhere here we can just go like, and then yf is, I guess we can leave that one like that is. A f1, B f1, and C f1. Okay, and then here we go A f B f C f, and with our T1, I guess for each of these we want to check if we are in the range. So we probably want to do like, we have 2 T's that come out of this. 4 T's, T. If T is in the range of, if T is less than 0 or T is greater than 1.0, continue. Otherwise, we sample that shit and we get the X value. So now we have like one specific X value that we want to like round, and probably like int from float after rounding, and then like clamp it into the canvas, probably. So we'll call this xf, and here we have x pixel here. And then I guess we probably just want to be like, the canvas at that point. So we probably want to do like, row x pix is equal to color, I guess. We don't have any like line thickness here yet, but we'll kind of figure that out later. And then here we can put in a color. And then I think that's fine. I guess this is kind of like out of bounds x still gets written to canvas. Smile, which is probably wrong. We probably just want to do like, this is I64, and then we say like, if x pix is less than 0, or x pix is greater than self width as an I64. I guess we do it the other way. We then set the color like this. Sure. Should we try? Oopsies. What do you think the chances are that we can fucking draw some Bezier curves? Draw me a Bezier, please. AB, point C, green. We do need this thing to be a int cast. Can we just do one, out A ppm? Okay, so A is fine. Oh, no fucking way, dude! That's close. Look at that. Okay, so now we have the problem where we actually may need to be many x positions for a given y, right? If your thing is completely flat, you have like a range of values that you're trying to set, right? So we probably want to, I'm actually kind of shocked that that worked, to be honest. I was expecting it not to. I guess we need to write out some kind of like, what do we do for the line drawing? The line drawing will give me a clue. Here we looked at, we looked at the next y value, and we just drew everything up until that point. That seems reasonable. That seems reasonable. So how do we do that? So we say here, give me y plus 1. Okay. Probably here we really only care about t1, and then t2. We're gonna be like x1 is from t1 and x2 is from t2, and then we probably have to like sort these things in some way. Probably. And then probably we have to do like a +1 somewhere as well when we do some like ranging. Yeah, that's what we did up here. Because if they're the same, if we're drawing like completely vertically, right? This is going to be x1 is going to equal x2, and if we try to like memset arrange, we need to do x2 plus 1 so that there's like one value in here, you know? You know? So we do this, x1, x2, and then we clamp each of these. Sure. So then we can go like self clamped x1 pix. X2 is x2, and then we can kind of memset the row. However the fuck we get the row. Memset the row from x1 clamped to x2 clamped to the color. That should be a little bit better. Fuck. Fuck. U size, I guess. I'm surprised that this clamped X doesn't return a U size, but whatever. It maybe should, because I don't really know in what world we could clamp our X values to something that's not in the range of the canvas, which has to be a U size, but... Oh, this actually isn't working either. So, why the fuck not? I would expect that these clamped X values are supposed to clamp ourselves from 0 to the width, right? So, in what world, how is it possible that the clamped value is outside of the row? How is that? Like, that shouldn't be possible. Should not be possible. Why? Can we just like zig build and GDB args? So we have x1 clamped, x2 clamped. Oh, they're not out of range. They're fucking in the wrong order. So we need to do like min x1, x2, and max x1, x2. So much just like what the fuck code going on. Okay, so now he's mad about like integer part of floating point value out of bounds. So px2f, p hello, really? Oh, we need to go like up, backtrace. We would just want to go frame 7, px2f. Okay, sure. So why is that happening? I guess like the y value could be out of range of the curve. That's possible, right? We have, yeah, we're kind of at like the maximum position for the whole curve, and then we're trying to go farther. So can we just instead like less than max y? Does that kind of fix our problem for us? Not that I really know if that's like reasonable, but I think that like solves the bug. Okay, so now we have a line that looks... No, there's still bugs. There's a problem here. So why is this happening? We should be writing at every single y value. We probably are writing here, we're getting like lengths of 0, would be my guess. Like x length of 0 in these cases. Which means that we've fucked something up. We probably want to just go like, yeah, like here as well. We've done something fucking stupid. And we're still crashing in some cases. What's going on here? T2 is nan here. Because where did like T2s come from? T2s came from like trying to go y plus 1. Which is kind of surprising. Because now our y should be fine, right? We should have like max y. We're definitely like in range. Oh, maybe not actually. I guess. Yeah, I guess because one of these points, if we have like something that's like this, right? A, B, or A, B, C, right? We can't, there are some Y values that will never get hit over here. Right? So that means that if we want to like if we want to find like the bounds of this, that's kind of harder. I guess it's fine to use this bounding box. That's not crazy. Right? We know that everything in the line has to be within these 3 points. It's just some parts of this line will not exist. Which is fair. That's like totally reasonable. So let's go back to doing whatever the fuck we were doing here. So we had like we were greater than less than or equal to, we had y plus 1 here, and we just say like if any of the t's are invalid, we just like fuck off. He actually still doesn't like that, huh? Did I build? Did I save? Okay. So what's going on there now? I think we're just in the same case. We have x2f is not a number. So we have t1, t2 is not a number. So is it that like t2 is less than 0.0? Oh, fucking nan math. So we probably just have to like invert these conditions. T1 is less than this, and T1 is less than this, and T2 is greater than this, and T2 is less than this. Because the nans are going to be like, they're just going to say false no matter what, because you're comparing with nan doesn't give you anything sane. Oh, still no, huh? Okay. Okay. Okay, yeah, so why is this failing? We shouldn't be in this case, unless I forgot to type build. No? Did I forget to type save? Oh. I have to invert this whole thing. Shut up. Everything's so hard. There we go. Okay. Still got some crashies, huh? These do look fucking out of bounds, huh? Oh wait, maybe not. P. Oh yeah, that is just out of bounds. So clamped Y is returning us in the range of calc height. And here, so that means that this has to be. I mean, it might just. What did we do? What are we doing for other clamp Ys? We're just doing less than on all of these. Okay, so we just do less than here as well. Fine. Fine. If you're gonna be like that. All right, so that's looking good. It looks like we're getting through most of the letters now. Yeah, we didn't crash, so that's a big win for us. And now we just gotta figure out why in some cases we're leaving holes. But that is, we're fucking getting somewhere. Look at that. Look at that fucking clean ass O, man. That's not good. That shouldn't happen. There's a bug there. Right, you're looking at this and there's a solid line drawn between, unless we're like drawing solid lines where we shouldn't be in the Bezier curve rendering, it looks like we are probably accidentally yeah, we're literally, so we're misdiagnosing some things that are supposed to be Bezier's lines, which is probably from this fix me right here. Right? We're like on the last contour point, we're just like, yeah, always a line, get fucked. Which isn't true. Okay, but I would like to fix the fact that in some cases, we're seeing nothing. So it could be from this, right? That's definitely an option. Or it could be from the fact that this range is 0. And I would like to diagnose that. So maybe we go here and we say, let's only look at the letter B. Or maybe the letter, yeah, the letter B is probably fine. Okay. And now can we go back to the letter B? Where the fuck that is here. Oh, it's fucking sorted by time. Okay. And I would like to see if we are ever seeing cases where the length, okay, so first of all, are we ever seeing cases where this happens? Skipping due to T. Right? Let's just see if that happens. I don't know if I don't know if I think it should or should not. But oh yeah, we do have a bunch of them here actually. Like a lot of them. Okay. So I guess if T2 is nan, we might just want to use like this, we might just want to say, okay, sample 1 pixel at T1. Yeah, because we can imagine, like, we can imagine for sure a case where we're like, we're trying to draw the bottom of this curve down here, right? And we're trying to sample like down here as well. And we just can't. So that's, but I don't know if that's kind of what I expect to be the problem here. What we could do is in the case where we're skipping here, try, can we like at least log what the 2 options are? Okay. So in a lot of these, just both T values are out of range? Oh, sure. Wait, no, that's totally reasonable, actually. That's like almost expected, right? Because like we said before, when we're drawing this Bezier curve with these 3 points, all of these values have to skip. So that's pretty reasonable. That's super, super fucking reasonable. In which case, if that's all of the cases that we're skipping, where they're all like hella out of range, then probably we're hitting the case where the row size is, the length is 0, right? So can we say like, if x2 clamped minus x1 clamped is equal to 0, std debug print nothing rendering sag. Right? This is probably more the problem that we're hitting. How? So these are kind of like alternating. Also kind of weird. Also kind of weird. But, oh, I guess maybe that makes sense. Maybe, I'm not sure. If like we're rendering like small quads, small Bezier curves over and over again, we might be alternating between these cases a lot. So maybe we should just say, can we just like x2 is sampling the next point in the curve for the next y value. Yeah, we should say we should fill up everything from here to the next y value. That makes sense. Now, if that distance is 0, we should at least draw 1, which makes me think that this should be like this. That's a lot better. Oh, but we actually don't want to just, it can't be x2, it has to be the bigger of them. So it actually has to be here that we increase by 1. Oh, there it is, baby. That's looking good. And now, oh, tell me that's not a fucking curve, baby. That's pretty sick. That's pretty sick. And what's sick about this is it's like super fucking precise now, right? So to do like the masking stuff now, we can easily say, as we scan from the top to the bottom, right, we now can calculate the bounds of our thing really easily because we can just iterate every curve in our glyph and say, give me the fucking x values for this value, for this row that we're iterating. But I think that since it's 420, blaze it, bless up, shut the fuck up. I think we call for today. This took a lot longer than I thought it would. Like, a lot longer than I thought it would. But this is pretty damn sick. Actually, can we run it? Well, let's, before we call it, can we render all characters? And by all characters, I mean all of the characters in the range of A to Z, because I don't care about the other ones, because we are very biased towards English. And actually, can we take off these, like, fucking points? Like, fuck. Those don't need to be drawn anymore, so we can kind of just get rid of this shit. A, B, C, D, E, F, G. That's okay. That's pretty fucking sick, dude. I mean, this is a bug, right? At the end, we have a bug at the when the contour is at the end of the loop. But let's make this bigger and like just sing the alphabet a little bit longer. H I J K L M N O P. Oh, it looks so good, man. Q R S T T U V W X A B X Y Z C D E. Who fucking knows? Yeah, that's looking pretty good. I wonder if this is right. That feels kind of that doesn't look right to me, but it might be. Where was that like font rendering site that Two Step sent me to? Here. Can we look at the letter H in here? Oh no, that's right. That does look kind of right, huh? I thought this looked kind of fishy to me. But this is kind of fine. Okay, H I J. Is this what the eye's supposed to look like? The dot at the top is so square. I guess it is. Hello? Oh no, I'm lost. J K L M N O P Q R S T U V W X Y Z. Hell yeah, dude. That's pretty sick. I think, like, for the most part, for the most part, it looks pretty damn good. I'm pretty sure that our Bezier curve rendering is right. And so, yeah, we just have to fix the curve thing at the end and then fill them in. And we'll look at that tomorrow. You looked at layers for so long, you forgot what it's supposed to look like. Yeah. Okay, yeah, I'm quite happy with that progress. It's went slower than I thought it would, but also it was more interesting than I thought it would be. So I think we're kind of chilling there. Thanks for watching, guys. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It's 4:20 Pacific time now. Blaze it, bless up, shut the fuck up. It's 4:20 Pacific time now. So anywhere between 4 hours ago and now is probably when you should expect to see us live. If you're watching live, there's a YouTube link in the Twitch description where you can check out previous VODs. They're organized into playlists for different projects. You might want to check those out. There's a GitHub link in the Twitch description if you want to see the source code for this. It will go up eventually. It's pretty shit right now, but it might get better. Otherwise, I think that's all we want to plug for today. Yeah, YouTube, peace out. Twitch is fun, someone to raid.